Hello children, how are you all? Welcome back to our chemistry class. Do you remember what we were learning in the previous class? We were dealing with a new chapter, Language of Chemistry. And there we have studied what a chemical reaction is. We also have seen a number of chemical reactions. We learned how to write word equations for all these chemical reactions. And also we have seen to write simple equations using symbols and formulae for all these reactions. Now, today we are going to learn the conditions necessary for a chemical reaction. Children, there are a number of conditions which will help a chemical reaction to occur. Sometimes one condition will be enough for the reaction to take place, and otherwise maybe more than one condition is required for the reaction to occur. Now let us see the conditions one by one. The first condition for a chemical reaction to take place is close contact. Okay, it is close contact. We have already learned that when a chemical reaction occurs, there will be the reactants present, and these reactants undergo a chemical change. As a result, we get the products. Isn't it? Now, if there are more than one reactant, that means if there are 2 or 3 reactants, in that case, anyway, there should be a close contact between the reactants. Only then the reaction will occur. I shall tell you a very simple example. Just take a small piece of sodium, add it to water. Immediately, you'll be able to see the reaction take place very vigorously. Sodium reacts very fast with water. It darts around on the surface of water and immediately catches fire. The reaction is very violent. Just watch the video. What have you seen in the video, children? You might have seen that the reaction between sodium and water is very violent. Here, as a result of the reaction, sodium catches fire and the resultant solution in the beaker turns into a compound called sodium hydroxide along with the evolution of a colorless, odorless gas which burns with a pop sound, and the gas is hydrogen. If sodium was kept separately or if it is kept away from water, the reaction would not have taken place. When sodium came in close contact with water, the reaction happened. Okay, so shall we try writing a chemical equation for this reaction? Sodium, metallic sodium, when it is added to water, what happens? It reacts together. Sodium reacts with water very vigorously, giving you sodium hydroxide and hydrogen gas. Sodium hydroxide and hydrogen gas. This is the word equation for this particular reaction. Okay, so as sodium is very reactive in the presence of water, normally what we do is sodium is stored in kerosene. It's stored in kerosene so that we can avoid the contact of sodium with atmospheric moisture. Even that is enough for sodium to react. So this is an example where we find the close contact is enough for certain chemical reactions to take place. Okay, I hope this is clear. We shall try writing a chemical equation for this reaction. Sodium reacts with water, giving you sodium hydroxide and hydrogen. How do we write hydrogen, children? It should be written as H2 because one molecule of hydrogen is made of 2 atoms of hydrogen and hydrogen is a diatomic element. I hope this condition is clear to all of you. Now moving on to the second condition. The second condition is the solution form. That is, For certain other chemical reactions to occur, the reactants should be taken in their solution form. Okay, so the second condition is solution form. Solution form. I shall simply tell you a very simple example. Just think about two different compounds. The compounds are silver nitrate, silver nitrate and sodium chloride. Silver nitrate and sodium chloride. These two substances are available in their solid state. Now, once when we mix these two substances, or once if we keep these two substances in close contact, you won't find any particular change taking place. That means chemical reaction does not occur. Now, what you have to do is just make a solution of silver nitrate. How can you make a solution of silver nitrate? Add a little bit of water to silver nitrate. Just make an aqueous solution. Now, prepare a solution of sodium chloride in another test tube. Now, try to mix these two solutions together. Once when you mix these solutions together, you will be able to see that there is a change taking place. And the change is nothing but the formation of a precipitate. What do you find here, children? The formation of a precipitate. What is a precipitate? Here, and let me write the products first. What are the different products that you get? The products are silver combines with chloride. I mean, the positive part of this compound reacts with the negative part of the second reactant, and as a result you get silver chloride. This is the first product, and the second product is the positive part of the second reactant combines with the negative part of the first reactant, and the second product is sodium nitrate. That's how we write the products. Okay, here we write the products in this way. Silver combines with chloride ion, sodium combines with nitrate ion. That's how you get two different products. And I told you that there will be the formation of a white precipitate. It looks like a curdy white precipitate. Have you seen curd? And you might have observed how curd looks like, isn't it? Similarly, you will be able to see a thick white substance formed inside the test tube when you mix up silver nitrate with sodium chloride. And that is of silver chloride. Silver chloride will be seen here as a precipitate. Do you understand? So thick, curdy substance that is formed here. It may not be curdy in all the chemical reactions. It's a thick substance. A precipitate is a thick, solid substance that is formed when two solutions are mixed together. But this kind of precipitate will not be seen in all the reactions. Okay, keep that in mind. So here, silver chloride is a thick, white colored substance, and it will be formed when silver nitrate reacts with sodium chloride. Have you followed, children? So here, what did you understand? Once when these two reactants are taken in their solid state, and if you simply mix them up, the reaction will not take place. But once if you take them in their solution form, and when they are mixed together, the chemical reaction is occurring. As a result, you find something newly formed, and that is also a visible change is observed here, and that is the thick, curdy, white precipitate, and that is of silver chloride. Okay, so we shall try writing a chemical equation for this particular reaction. How do we write the chemical equation, children? The first one is silver nitrate, AgNO3. It's silver nitrate reacts with sodium chloride, is NaCl, gives you silver combines with chloride, isn't it? So we get the product as silver chloride along with sodium combines with the nitrate radical, so NaNO3. So here silver chloride will be seen as a white precipitate. Precipitate is a thick solid substance that is formed. And my dear children, the precipitate will not be white in color in all the chemical reactions. Okay, it may be white, it may be green in certain reactions, in certain other reactions it may be yellow. So the color of the precipitate differ according to the reaction or according to the products that you get. So silver chloride is a white precipitate. I hope this is also clear to all of you. So we have seen two different conditions which are necessary for a chemical reaction to take place. Now we shall see the next condition. Before we move on to the next condition, I think you can watch a video showing the precipitation reaction.
So now that we have these two aqueous solutions, the AgNO3 and then the NaCl, we'll mix them together. Remember, they're both aqueous, so they're split apart into their ions. When we do that, this is what happens. The AgNO3 and NaCl, they change places, a double displacement reaction, and we get AgCl, which is a solid. And that's a precipitate. It's going to fall over time to the bottom of the test tube or the beaker, and then what's left in solution will be those two ions, the sodium and nitrate ion.
Here we go. I'll start with the iron 3 chloride. You can see that's a clear yellow solution. I'm going to add the sodium hydroxide to it. You can see the precipitate this created is kind of a brown gelatinous precipitate.
I hope you have understood how a precipitation reaction is taking place. Okay, so we have seen two different reactions in the video and there we have seen how a precipitate is formed. Now we shall see the next condition. The next condition necessary for a chemical reaction to occur is heat. Certain chemical reactions will take place only when you heat the reactants. When you heat the reactants, the reaction will occur. If you do not heat them, the reaction will not take place. I think we have already seen such a reaction in our previous class, isn't it? What was that reaction? We have already seen when calcium carbonate is heated. Calcium carbonate is heated. What happens? It decomposes, isn't it? It decomposes to give you calcium oxide and carbon dioxide. As this is a reaction which we have already seen, I did not write the word equation for this reaction. I think this is clear to all of you, isn't it? So this is a chemical reaction which will take place only when you heat the reactant. Okay, if calcium carbonate is left without heating, the reaction will not occur. This is a very simple reaction where heating is required for the reaction to take place. So, my dear children, I am just giving you only one or two examples wherever these conditions are used. Okay, but don't think that these are the only reactions where heat is required or where a solution form is required. No, there are a number of examples for all these chemical reactions. Have you followed where these conditions are used? Now, one more chemical reaction I'll tell you where heating is required. We have already learned that iron filings, when mixed with sulfur powder, it simply remains as a mixture. I hope you remember it, isn't it? And you can see that iron powder is simply like a brown colored substance, and once when it is mixed with yellow colored sulfur powder, when this mixture is observed, it will be remaining as it is without any chemical reaction. Let's watch a video. have you seen in this video, children? Iron filings when heated with sulfur. Iron filings, when it is heated with sulfur, it got converted. It got converted into a black solid mass. And what is that? That is iron sulfide. And what is the valency of iron in this compound? Can you identify the valency of iron in this compound? What is the valency of sulfur? It is -2, isn't it? -2. Okay, so what will be the valency of iron in this compound? It will be +2. How did I get it? That is why no numbers are written at the bottom. Isn't it? There are no numbers written at the bottom, which means both the elements will have the same valency. So I can call this compound that I get here as ferrous sulfide. Isn't it? It is iron sulfide, but as iron shows variable valency, this compound, the valency of iron is +2. So it is called ferrous. The compound is ferrous sulfide. Ferrous sulfide. It is ferrous sulfide. So what did we see in this reaction, children? Here, iron, when heated with sulfur, a new compound is formed, and that compound is ferrous sulfide, which is seen as a black solid mass. Okay, or it is a black solid residue that is left behind inside the dish. Okay, it is a black colored solid residue. Have you followed? So here we have seen that heating is required for this reaction to occur. Again, in this previous reaction, calcium carbonate, here we won't be able to see any particular change, but the change is taking place because new substances are formed. Isn't it? Calcium carbonate is a white colored solid substance. On heating, you can see the evolution of colorless, odorless gas. My dear children, here, though carbon dioxide gas is evolved, don't think that there is brisk effervescence. Brisk effervescence will be seen only. What do you understand by the term brisk effervescence? Brisk effervescence means strong gushing out of a gas. I mean, strong bubbles evolved when a particular acid reacts with a metal carbonate or a bicarbonate. We have seen such a reaction in the previous class, isn't it? So here also carbon dioxide gas is evolved, but how this carbon dioxide gas will be seen evolved? Not as bubbles, because there is no liquid medium used here. It is simply heating of a metal carbonate taking place. So when heating this metal carbonate, what happens? It decomposes, giving you carbon dioxide, a colorless, odorless gas, which turns lime water milky. Lime water milky. What is lime water? Lime water is a solution of calcium hydroxide. Solution of calcium hydroxide. That's called lime water. It turns milky. Milky means it is calcium hydroxide solution is a colorless clear liquid, water-like liquid. On passing carbon dioxide through that liquid, what happens? It just turns into a milky color, which means carbon dioxide is undergoing, or carbon dioxide is reacting with that reacting with that lime water. We'll be learning about all those things later. Just understand this reaction at present. Okay, so calcium carbonate, on heating, you can see the evolution of colorless, odorless gas evolved, and that is of carbon dioxide. And what will be seen as a residue in the test tube? Again, a white colored solid will be left behind in the test tube, and that is calcium oxide. Calcium oxide is also a white colored substance. Okay, here there is no precipitate. How will a precipitate be formed, children? When two solutions are mixed together. Here we are not using any solution, isn't it? So it is simply a dry heating test. Followed? So this is a solid residue which will be left behind, and ferrous sulfide here, which is obtained as a result of heating iron filings and sulfur powder, is also a residue or a solid black colored substance left behind. Okay, so we have seen three conditions necessary for a chemical reaction to take place. Now we are moving on to the the fourth condition. Fourth condition. Okay, so three conditions we have seen. The first condition was close contact. Two reactants, once when they are brought close together, once when they are just placed together, that's enough for the reaction to take place. I told you, for all chemical reactions, close contact is not enough. Okay, we have seen one example for such a reaction. Now, in the second case, we have seen solution form. Reactants should be taken in their solution form, only then they will be reacting. The third condition is heating. The reactants will undergo a chemical change only when you heat them. So three conditions we have seen. Moving on to the fourth condition, light. Light. Certain chemical reactions occur only in the presence of light. Are you familiar with any such reactions, children? Yes, photosynthesis. Photosynthesis is actually a chemical reaction. Plants prepare food for themselves by the process called photosynthesis. What's happening there? Carbon dioxide reacts with water in the presence of sunlight and chlorophyll, giving you oxygen along with glucose. Isn't it? So this is how plants prepare food, and in this reaction, what is necessary? Light is necessary. Photosynthesis is a chemical reaction which will take only in the presence of sunlight, and it will not take place in dark. Okay, again there are a few chemical reactions which will take place only in the presence of light. That is silver compounds. Compounds of silver normally undergo decomposition in the presence of light. Silver chloride, silver nitrate, all these ones, when they are exposed to light, they undergo decomposition. They split up. Have you followed, children? I'll just give you one example. Silver chloride, when it is exposed to atmospheric, when it is exposed to sunlight, it decomposes, giving you silver and chlorine. Okay, again, silver nitrate undergoes decomposition, giving you silver, nitrogen dioxide and oxygen. And these examples are not mentioned in your textbook, so you need not worry about it. You can just learn one example, and that is photosynthesis. Okay, photosynthesis is a chemical reaction where sunlight is required. Light is required for this reaction. Now let us see the last condition. Certain chemical reactions will occur only in the presence of a particular substance called a catalyst. Catalyst. I've used this term catalyst in the previous class. Catalyst. The fifth condition is the presence of a catalyst. What is a catalyst? Do you remember a chemical reaction which we have learned in the previous class using a catalyst? I think you all remember it. It is the action of heat on potassium chlorate. Potassium chlorate. I don't know whether you remember the formula of potassium chlorate. It's KClO3. KClO3. Okay, you haven't learned the radical chlorate, so you may find it difficult, but just understand that this is the formula of potassium chlorate. Okay, potassium chlorate, when it is heated, it undergoes decomposition. It undergoes decomposition to give you potassium chloride and oxygen. To give you potassium chloride and oxygen. For all these chemical reactions, children, word equations are given in your textbook. But I think by now you have understood the convenience of using these symbols and formula. Isn't it? Otherwise, you will have to write the whole word like potassium chlorate, potassium chloride, oxygen. All these are to be written in words. It's a time-consuming process, isn't it? So I think now you can understand if I use their symbols and formulae. Okay, so here potassium chlorate, when heated, it decomposes to give you potassium chloride and oxygen. But it takes a lot of time for this reaction to occur. You will have to heat for a long time for this decomposition reaction. So how can you speed up this reaction? How can you make this reaction take place faster? By the usage of a catalyst. And I hope you remember the catalyst that we used in the previous class for this reaction. The catalyst is manganese dioxide. Manganese dioxide. Manganese dioxide is a catalyst that we use here in this reaction. We do have a number of catalysts used in various reactions. And now let us see what is a catalyst. A catalyst is a substance which changes the rate of a chemical reaction, which increases or decreases the rate of a chemical reaction. What do you understand by the term rate? The speed. How fast the reaction will take place. Or if you want to slow down a chemical reaction which is taking place very vigorously, you can just slow down a chemical reaction with the help of catalyst. In this reaction, manganese dioxide is used to increase the speed of the reaction. Okay, so a catalyst is a substance which increases or decreases the rate of a chemical reaction. And there is one more point to be added: without itself undergoing any change. Here potassium chlorate is the reactant used. Okay, and this is undergoing a chemical change, and as a result you get potassium chloride and oxygen gas, isn't it? That means potassium chlorate is undergoing some kind of rearrangements in its number of atoms, and simply the arrangement of atoms of different elements has taken place, and that's how you get products on the other side, isn't it? But manganese dioxide is just acting as a spectator, like it simply just remain there in this reaction. It itself does not undergo any change. It's not undergoing any particular change. Have you followed? But it has a major role to play, that is, it increases the rate of this chemical reaction. So what is a catalyst, children? A catalyst is a chemical substance which increases or decreases the rate of a chemical reaction without itself undergoing any change. Have you followed? It itself will not undergo any change. Okay, after the reaction also, manganese dioxide will be remaining same without any change. Okay, so that term is very important. You have to learn the definition of a catalyst thoroughly. So what is a catalyst? It is a substance which increases. A catalyst is a substance which increases or decreases. What will it increase or decrease? The rate of a chemical reaction. Rate of a chemical reaction. Okay, it increases or decreases the rate of a chemical reaction. What is a very important point there? Without itself undergoing any change. Without itself undergoing any change. Without itself undergoing any change. Okay, it will be remaining intact without any change. Without itself undergoing any change. Increases or decreases the rate of a chemical reaction. Okay, when you write the definition of a catalyst, all these points are to be included. So I think you are clear with all the 5 conditions necessary for a chemical reaction. Okay, so now let's try to recall all the 5 conditions one by one. The first one is close contact. The second condition is the solution form. The reactant should be taken in its solution form for the reaction to take place. The third condition is heat. Heating is required for some of the reactions to occur. Now, the fourth condition is the presence of light. Now, the fifth condition is the presence of a catalyst. Certain reactions will take place only in the presence of a catalyst. So here, children, manganese dioxide, if not used, the reaction will take place, but it takes a lot of time. But on adding manganese dioxide, what happens? The reaction occur very quickly and you will be getting the products very fast. Okay, so this is all what we have to learn regarding the conditions of a chemical reaction. I hope all the points are clear to you. So we'll wind up today's class. Thank you.